This is a EDEXCEL International A-Levels paper, Hastings Math. I'm doing the January 2023 paper, question 7. In my previous video, I said I would do 7A in a different way. So I just want to go over that. So this is 7A, but done in a different way. So if you want to just look over this working, this is using trig identities to do the 7A question instead of the sort of logical method that I did before. Okay, but if we look at 7A, oh, this will get a spot on my board. So 7A, just a quick recap in case you're just starting here, was to get dx dy, but sorry, dy dx, but it had an x in the answer. So this meant that we couldn't use our usual form of just getting dx dy and flipping it around. So we couldn't do this because then we'd get it with some sort of y's in the answer, and we didn't want that. We wanted with x's in the answer. Okay. So looking at this, first I did it with using a triangle and sort of manipulating it until you get to it. But another way we can look at it is using trig identities. So if we start with the function that was given, so the function that was given in the question was this, x equal to 3 tan y minus pi over 6. And we know that tan squared theta plus 1 equals to sec squared theta. This is a manipulation of identities that I won't go into right now, but this one is very useful to have memorized. And then using this, we can manipulate the answer to look the way that we want it to. Okay, so let's go ahead. So if I take this, first thing I want to do is divide both sides by 3 and get x over 3. And then when I look at this answer here, so now we have x over 3 equals to this whole thing. We can make this look like this part of it. Okay, so if we want to do that, then we would say well, first of all, we need to square both sides. So we square both sides. This becomes x squared over 9, and the other side becomes tan squared, and everything inside the bracket would just be your theta. So that's whatever is inside the bracket is your angle. Okay, so now we have it looking like tan squared theta. Just to rearrange this slightly, so obviously we want sec squared theta minus 1 would be equal to tan squared theta. So again, if you looked at the previous question, we're aiming to make it look like dx dy. So dx dy was looked like this part. So just if you worked it out, dx dy becomes this. Okay. So what we're doing is we're manipulating it. We're aiming for this 3 sec squared. So let me see where are we? Okay. Right. Tan squared theta, oopsie. Over there. Tan squared theta over here is this part. So it's equal to sec squared theta minus 1. So it's the same theta. Can just interchange it. Okay. And then we can take that -1 to the other side. +1 on both sides. Okay. We're almost there. So we're aiming, remember, for, we wanted our dx dy. I just want to write this down because it might not be obvious if you're just jumping into this question. If you use the chain rule to get dx dy from our C, tan becomes sec squared theta. So dx dy is 3 sec squared y minus pi/6 times by the derivative of everything inside the brackets, which is just 1. Okay, so we're aiming for that. This is just another way of getting it. I'm manipulating the original equation to look like this. Okay. So that was our dx dy. So we're nearly there. The only thing that's different now is the 3. That's where we're at. Let's take a look. We'll just keep it going. So the only thing we need to change is we need to times both sides by 3. And that will be, our final answer will be 3 sec squared y minus pi/6, which is our dx dy. So that's what we were going for, is equal to the 3 and the 9 cancel out, put a 3 at the bottom, and then 3 will times into that one. So we end up with, well, let's just do it in 2 steps. So 3 is, if you write it as an improper fraction, if you want 3 as the denominator, then you have to times it by 3. So 9/3 is the same thing as 3. 9 divided by 3 gives you 3. So we end up with x squared plus 9/3. And remember, this is equal. You can see on the left-hand side that this is what our dx dy looked like. So we know that the right-hand side is the same thing. So this is our dx dy. And last step, obviously, you can just flip it around because the question asked for dy dx. So flip this around, get 3/x squared plus 9 as dy dx in terms of x, which is what we needed for the question. So just to go back, make sure this is what we needed in terms of x, and we have it now. Okay, so that's the other way we could have approached this question. Good.